Okay, today we're going to look at doing some problem solving with right triangles. So we're going to take what we've done with the trig, all the sine, cosine, tangent functions, and we're going to use those, excuse me, we're going to use those to solve some different problems. But before we get to that, we need to look at two different vocabulary terms because you're going to see these a lot in trig. One is angle of elevation, and this is just the angle that's formed by a horizontal line and a line of sight to a point above. So for example, with this our little smiley face here, the angle of elevation is formed when that person looks straight ahead and then when they look up at an object. Okay, so that's our angle of elevation, will be this angle right here where I have the cursor. Our angle of depression is very similar, except that now it's if you're looking straight ahead and then you're looking down at the object. That's going to be our angle of depression, will be this angle right here. And we'll do a couple of examples here in a little bit where we can see how, and I'll show you some common mistakes that are made when doing angle of depression problems. Okay, so that's all angle of depression is, angle formed by the line of sight, by a horizontal line and the line of sight. So if you're looking straight ahead and then look down at the object, that's your angle of depression. All right, so let's look at a couple of examples. All right, so on this first one, it says an escalator from the ground floor to the second floor of a department store is 110 feet long. So let's start figuring out what we have here. So our escalator is 110 feet long, and it rises 32 feet vertically. So it rises 32 feet vertically. So there's our right angle. There's our problem. It wants the angle of elevation. Very important key right there. It wants angle of elevation. So that lets me know I'm looking for that angle right there. Okay. All right, so based on what we have, if we're looking for this angle, that means that 32 is our opposite, and this 110 is our hypotenuse. So I've got opposite and hypotenuse. Okay, so since we have opposite and hypotenuse, that's going to be our sine function. So we're going to use sine of our angle, which we don't know, so it's just going to be x. And equals our opposite side, which is 32, over our hypotenuse, which is 110. Well, at this point, we're done. There's nothing else that we can do by hand. We got to grab our calculator. Okay, so again, always check, and I know mine's going to be in degrees. I haven't changed on my computer, but always check those calculators. Make sure it's in degree mode. So now, since I want the angle, it's going to be second sine, and then my ratio, 32 divided by 110, which is about 17 degrees. Okay, so that's about 17 degrees. And that's it. That's our answer. That's our angle of elevation. Okay. All right, to the next example. We got two more. All right, so from the top of the tower, the angle of depression to a stake on the ground is 72 degrees. Okay, so basically this is what we have here. We've got a tower, and it says the angle of elevation. Now, one thing that I recommend doing is I recommend starting off our problem with a rectangle, with a diagonal. Okay, so this is our tower. That's our tower right there. It says the angle of depression is 72 degrees. A common mistake would be to put the angle of depression here. It's very common. I see it a lot. However, the angle of depression is actually right here. Because the angle of depression would be as if you were looking straight ahead and then looking down. That's your angle of depression. Not this one. Very common mistake is to put it right here. Okay, so our 72 degrees goes there. It says the top of the tower is 80 feet above ground. So this height of our rectangle is 80 feet. And how far is the stake from the foot of the tower? So our stake is here, the foot of the tower is here, so this is the value that we're looking at finding right there, that side. Okay, so we've got some values, but we've got an angle on this right triangle up here, and we've got two sides on this triangle right here. Well, part of why I want you to draw a rectangle is because if this angle is 72, that means that that angle is also 72 degrees. And that's one thing. This angle would actually be the angle of elevation from the stake. So your angle of elevation and angle of depression should actually be the same. They should be congruent every single time. They should be congruent. Okay, so just kind of keep that in mind when you're putting your angles in there. So if we were to put 72 here, there's no way that that angle could be 72. Just going to think about that when you're setting up problems. All right, so I've got what I need. So this 80 is going to be my opposite. And this x is going to be our adjacent. Okay, so I've got those values. Well, I've got opposite and adjacent, so that's going to be tangent. Finish my T there. I know my degree measure this time. It's 72. I know my opposite side, because remember tangent is opposite over adjacent, so that's 80 over. My adjacent side is x. Okay, well, again, on this one I've got a variable in the denominator, so I'm going to go ahead and make this a proportion. I'm going to put that over 1. Now I'm just going to cross multiply. So that's going to be x times tangent of 72 degrees equals 80. I want to go ahead and solve for x. I'm going to divide both sides by tangent of 72. And finally, I can just go ahead and plug that in the calculator because those tangents cancel each other out. So, all right, so I've got everything set up. I can just go to my calculator and go and type in what I have there. So I've got 80 divided by tangent of 72 degrees. And when I enter, that gives me my side length, which is, for this one's about 25.99. So we're going to go ahead and round it to the hundreds here. So it's about 25, excuse me, 0.99 feet. And make sure that we're looking at units. Okay, units are very, very, very important. Okay, and that's our answer. All right, final example. Okay, so in our final example, it says that an airplane rises vertically 1,000 feet over a horizontal distance of 1 mile. What's the angle of elevation for an airplane's path? Okay, so basically, we've got an airplane here. It's elevating. So again, we got a right triangle. Well, it's kind of a right triangle. All right, so it says it rises vertically 1,000 feet. So we're going to put 1,000 here. And then it says a horizontal distance of a mile. Now be very careful on problems like this. It says it's a mile. Our other value is in feet, so it can't be a mile. We need to use feet, which is 5,280 feet. Now we can set up our problem. And again, it wants our angle of elevation, so it's going to be this angle here. So it's going to be very similar to the first problem. We've got our 1,000 is our opposite, 5,280 is our adjacent, so we're going to use tangent of our angle, which this time we don't know, equals our ratio, so our opposite is 1,000. Our adjacent is 5,280. From there, there's nothing else that we can do by hand, so let's go and type it in the calculator. So I use tangent, so it's going to be second tangent of 1,000 divided by 5,280, which is about 11 degrees. So our angle of elevation for that airplane is about 11 degrees. And that's it. That's all for the examples. Thanks for watching. And be prepared for your quiz on Thursday.